All right, guys, today we're moving to 8.5, which is adding and subtracting rational expressions. And again, we kind of saved the best for last here. We do have one more section we're going to be doing on rational equations, but this is the last of the expressions that we're going to be looking at. And again, I want to just repeat it one more time that the word rational has the word ratio in it, which means that the same rules that apply for fractions apply to rational expressions as well. So again, if I'm adding fractions, obviously if it's like 1/5 plus 2/5, remember I keep my denominator the same. As long as it is a like denominator, I can add or subtract those numbers. And then I just simply add or subtract whatever operation I'm doing. So 1 plus 2 would be 3. So this answer would be 3/5. If I had 1/5 and I added 2/5 to it, it would equal 3/5. The more challenging thing is when we do not have like denominators. For example, let's say I have 1/3 plus 1/6. And so typically the way we would have written these in elementary school is we would have typically what they do anyway is they go ahead and stack these up vertically, okay? And so you would have tried to find a common denominator between 3 and 6. And really here what you're looking for is a least common multiple. We've been talking about a lot about greatest common factor, but when you're talking about fractions, actually you're going to use least common multiple in order to figure out what a common denominator is. So a least common multiple, I'm going to start with my biggest number and start with just that first multiple. So 6 times 1 is 6, and 3 will go into 6 as well. So I could use that as my common denominator. So a 6 and a 6. Obviously, this one is already set, so 1/6. Then you have to ask yourself, 3 times what would give me 6? Well, 3 times 2 is 6. So then I take that 2 and I multiply it by the numerator. That's really important because we're going to be doing something similar to that here in just a few minutes, which gives me 2. So now I can add those because I have common denominators, which means that would be 3/6, which would actually equate to 1/2. So you can see there how we need to do that if we have denominators that are not common. So let's go ahead and start with number 1. And the first thing you want to look at is you want to see if you do in fact have common denominators. And so you notice here I have 25 VU. Those are common denominators. So all I have to do is simply bring my work over. 25 VU. And then here, these terms, I just need to add them together. So 4V plus U plus 3V. And then I'm going to look for any like terms, right? My denominator is going to stay the same. So 25 VU. But here, you notice I have some like terms here. You notice I have a 4V and I have a 3V. So if we add those together, I'm going to end up with 7V plus U. And again, I don't have any factors that are in common in all 3 terms. It has to be in common in all 3 terms before I can eliminate anything. So this would in fact be my correct answer. Pretty simple, not really difficult at all. Again, we just have to ask ourselves whether we've got a common denominator or not. So now let's go on to number 3. Didn't mean to make that little mark right there, but I did. So here we go. Number 3, let's notice our denominators right off the bat. I have 3x and I have 4xy. Those are not common, okay? So they do have a couple things in common. If you notice, they both have an x here. So they both have an x. I don't need an x. I've already got an x in both terms, in other words. You will notice, though, that this one does not have a y, so it needs a y. So in order to do that, I'm going to have to multiply this by a y in order to get this term to have a y as well. You will also note that 3 and 4, they're not factors of one another. So I need to do the least common multiple. And so we're going to, again, it's counterintuitive, but when you're talking about least common multiple, you actually want to start with the bigger number. So let's think about the multiples of 4. You have 4, you have 8, you have 12, you have 16. And we could keep going, but we really don't need to. So now I'm going to think about the multiples of 3. 3, 6, 9, 12. Did you hear something repeated? As a matter of fact, you did. And you'll notice that the least common multiple, the least number that they share in common, is actually a 12, okay? Which means that I need to get both of these terms to come out to a 12. Well, what do I multiply 3 by to get a 12? I need to take 3 times 4, right? Notice 1, 2, 3, 4. So I need to also multiply by a 4 here, not just by a y, but also by a 4 in order to make this a 12. Right? Now I also need to make this a 12, which means that I need to multiply this whole thing by 3. Okay? So it's a lot like that problem we did just a few minutes ago where we were trying to find the common denominator. I had to multiply, in that case, I only had to multiply one number times 2 to get 6. But here, I'm having to actually multiply some things by both of them. Now, here's the other part we have to keep in mind. If I multiply the denominator by one thing in my term, I also have to multiply the numerator by that as well, okay? And the same on this side. So here's actually what my problem begins to look like now. Now I have 4y times 6y, and that's all over. Now let's think about what our common denominator is. 4 times 3 is 12, and I have an x and I have a y. So that now is my common denominator. And notice what happens. We're adding to that the same exact common denominator over here because I have 3 times 4, which is 12, and I have xy. So I have 12xy. So you can see what we were doing. We were getting where we had common denominator in both terms. But in order to get that common denominator, I had to multiply this bottom term by 3. Well, if I multiply the bottom term by 3, I have to multiply the top term by 3 as well. So it's 3 times x plus 5y. Okay? All right, let's go a little bit further with this. So now I'm going to go ahead and do some multiplication here. I've got 24y squared plus, now remember I have to distribute this 3 through both terms. Okay, so 3 times x would be 3x, and 3 times 5y will be 15y. Okay, and that is all over. Now I can write it as one common denominator, 12xy. What I want you to notice is look at these coefficients, okay? I have a 24 here, I have a 3 here, I have a 12, and I have a 15. Is there a GCF? Here we go with that again. Is there a GCF that will go into all of those numbers? Well, as a matter of fact, there is, and it's this 3 right here. 3 will go into all of these numbers. So what we're going to do is we're going to go ahead and divide all these numbers by 3. So if I take 3 divided by 3, that just becomes a 1, kind of just goes away. 24 divided by 3 would actually be 8. 15 divided by 3 would be 5. And 12 divided by 3 would be 4. So now let's rewrite out our new problem, our new expression, simplified, would be 8y squared plus x plus 5y all over 4xy. Okay, so that would be our final answer right there. So again, not very difficult. It's just like adding or subtracting fractions. It's just that you have to get common denominators even with variables, okay? Really, subtraction is no different, so I'm not going to spend a lot of time on that. The only difference is you have to think about the fact that you're subtracting. So let's actually work through one. I want to go ahead and do this. Common denominator here, 2b and 4ab squared, okay? All right, notice that those are not common denominators. They do have some things in common. We'll talk about those right now. We actually need to find an LCM, right? If I'm talking about the common denominators, I got to find an LCM. Well, notice I'm going to start with the biggest number, which is 4, and I can, in fact, make a 4 with a 2. So we'll go ahead and use that as our common denominator. In order to do that, I'm going to have to multiply this entire expression by 2. Okay, so 2 times 2 would give me 4. So I end up with 4b over here, but I need one more b, which means I need to multiply by another b. And you also notice that this term has an a, and this one does not have one, so I'm going to have to multiply by an a as well. So really what I'm multiplying by, and I'm just going to cross that out, I'm multiplying by 2ab, okay? So hopefully that makes sense. And this would in fact be my common denominator, okay, 4ab. So what I'm going to have to do, if I multiply this bottom by this, means I'm also going to have to multiply the top by that same thing, by that 2ab, okay? So let's write out what this looks like now. I've got 2ab times 2, which would make 4ab, Okay, and I'm subtracting, now notice this, I'm subtracting A. So I'm just going to go ahead and write subtract A. But now notice here I have subtraction of a negative. Subtraction of a negative. When I subtract a negative, that's a double negative. That actually becomes a positive 4B. Okay, positive 4B. And this is all over 4AB squared. So I just want you to note that that subtraction symbol is going to change the signs on everything that's after it, okay? Now notice up here, I don't really have anything that's in common in all three terms. These two have an A, but that one doesn't have an A. These have a B, but that one doesn't have a B. These two have a 4s, but these, and that one, matter of fact, has a 4, but this one does not. So there's nothing really in common that I could pull out of here, which means this would be my final answer. Sometimes they are just that quick, okay? The big thing is finding that LCM and making sure that you get that common denominator that you can use to subtract, okay? If you have any questions or concerns, make sure to reach out to us, and we'd be glad to help you with those. Thanks, guys.